Good evening. Am I audible? Yes, anyone can unmute and speak up. Am I audible?
Yes,
Yes.
sir.
So, welcome to week 3 of the live interactive session of the Neural Science for Engineers. The course instructor is Professor Vikas V of Nimhans, Bangalore, and I am the PMR of Teaching Assistant Vikas Pandey from IIT Jodhpur. Okay, sorry. The date has not been changed. It is 13, right? Okay, 13. Okay, so this is a brief about me. I am a PhD scholar at IIT Jodhpur in IDRP Space Science and Technology. I have a background of MTech in VLSI, BTech in Electronics and Communication. I have worked as a R&D engineer, online faculty, and robotics trainer. For details, you can visit my portfolio. The schedule of this class remains the same in general, Tuesday 6 to 8 p.m. and Meet link will also remain same. All the recording of this are available on YouTube channel mentioned here. And in case you have any issues or queries, you can even write to me over this email. Last class, I think the complete recording was not available because only around 1 hour recording was possible. After that, the software was unable to capture it. I'm not sure why. Okay. So before moving to questions, if you have any doubt, any questions, feel free to ask. Unmute yourself and speak up. I'll not be able to seeing the messages because while taking the class, I'll only be able to respond to the voice message, as you can see. So anyone having any questions? Yeah, Paritosh, your query was solved.
Sir, I did posted that over the portal, but I didn't get the response yet.
Okay. Uh, Actually, that day, sir said that to share his email with you all, and I thought it might be available in the portal or the list that was shared to us, but it was not there. So I am
No,
also
sir.
not able to get sir's email, okay, so that I can forward these queries to him. Anyway, let's hope he joins in some subsequent class or today. Then we'll be able
Okay,
to
sir.
ask him. Yeah. Okay.
Yeah,
Any other
thank you.
questions? Okay. So let's move to questions. Okay. So, what is the primary function of autonomic nervous system or ANN? Not ANN, ANS. Okay. Is it for voluntary muscle movement, regulation of body functions, sensory perception, conscious decision making? Which one of these is correct? Yes. Anyone?
Regulation of body functions.
Regulation of body function. Yes. Any other answers? Yes. Anyone? Harisina, uh, Chitish Kumar.
I also think it's the body function.
Okay. Yeah. Are you joining this class for the first time?
Yeah, the interaction session for the first time, yes.
Okay. Yeah. Before,
Actually, I joined the course late, so
okay,
I'm in
not
the
an
middle
issue.
of.
So,
Sorry.
yeah, can you introduce yourself, like your academic or professional background?
Yeah, I'm Kshitij. I am currently working as a project scientist in IIT Kanpur in the Department
Okay.
of Biological Sciences and Bioengineering.
Okay. Great. Uh, I think Harishina, you have also joined for the first time, right?
So this is the
Yeah.
first time I'm joining this
Yeah.
interactive session.
Yeah. Can you introduce yourself?
I'm
Like,
studying in SSN Engineering College of second year B
okay. Great. In which department?
biomedical.
Okay. Great. Okay. So, moving forward, let's say it is the regulation of body functions. So, as we all know that autonomic nervous system is responsible for regulating body functions which are not voluntary but involuntary, right? Which we don't control. Okay, like heart rate, respiration, digestion, and other internal functions. Fine. So two is B is correct. Let's move to the next question. Which division of the nervous system is responsible for processing sensory input, initiating motor responses, and coordinating higher level cognitive functions? Is it central nervous system, peripheral nervous system, autonomic nervous system, or enteric nervous system? Yes, anyone?
CNS.
CNS. Okay. Processing sensory input and then initiating motor response. Okay. Yes. Any other answers? Yes, anyone? Am I audible? Because here there is some electricity uh, power. There is power cut for some repairing. That might be the reason that my internet might not be stable. So, am I audible clearly?
Yes, sir.
Okay. Okay. So, it is the central nervous system consisting of. So, central nervous system consists of brain and spinal cord. These together are called as spinal cord because many a time uh, in quick response where we need this reflex actions and all, actually sensory inputs are processed in the spinal cord itself, right? So we cannot say that it is done in the brain only. Okay, some part of processing is also carried out in the part that is the spinal cord. This processes the sensory input, also initiates motor responses, and coordinates high level cognitive functions. Clear till here? Any doubts?
No, sir.
Yeah. So, what are the primary effector organs of the motor division of the nervous system? Is it glands, skin, muscles, or eyes?
Effector will be muscles.
Muscles, yes. So, are these questions too simple today?
No, sir.
Eh,
Sorry.
It's fine, right?
Uh,
Right,
Because,
Kshitij.
yeah, okay. So, in fact, muscle is the primary effector organ of the motor division of nervous system. Okay. These are responsible for voluntary as well as involuntary movements. Fine. Yes, Chitish Kumari, are you trying to say something?
no, no, I was just saying, I was just responding to the question you were saying, are
Yeah,
these a little
yeah,
easy? I think
yeah.
for me, yeah.
It's easy, right? Yeah, we will gradually move. I think in this week, it was a bit very straightforward questions which I got. So let's go with this.
Some lectures were
In the pre
easy, the other two are tough.
Yeah, the week one and week two were a bit tougher compared to this.
Okay. Okay.
Yeah.
So these are also available on the portal, right? The SWAM portal.
Yes, these are available in the SWAM portal. If you go down, there is a section called as live interactive session. Just below the week one, week two, week three, there is live interactive session. There you can find all these videos. There a link will be given. If you open that link, you can check all the videos. Okay.
Thank you.
Yeah. Okay. Which of the following sensations is not classified as a special sensation? Is it taste, touch, smell, or hearing? Yes. Anyone?
Touch.
Touch. Why?
I remember, like, sir has mentioned that uh, the smell part and the taste part is the chemical. Uh, Taste is the chemical olfaction. Hearing
Taste
is
is
somewhat related to electromagnetic part.
okay.
And one more thing was there, which was yeah, eye. Our eye was related to no.
Mhm.
Eye was related to electromagnetic part. Hearing was the mechanical part. So
Mechanical
I
part.
can't
Yeah.
relate anything to touch.
Mechanical and uh, eyes. You are saying are electromagnetic,
Electromagnetic.
and smell is olfactory.
Olfactory.
Okay. And touch is something that is not classified as special
A
sensation.
special.
Yeah. Or if put in very simple terms, uh, the senses that are processed via the cranial nerves. Okay, they are called as special sensation, and they include vision, hearing, taste, and smell. Touch is not included, and it is not uh, processed through cranial nerves. Okay? Touch is a general sensation, not a special sensation. Okay, so this is right. Okay. What are the primary difference in the arrangement of gray and white matter between the cerebellum and spinal cord? Gray matter is on the outside in the cerebrum and inside in the spinal cord. Cerebrum is the brain part, right? The top part that we are calling as brain. Okay. White matter is on the outside of the cerebrum and inside of the spinal cord. Gray matter is on the inside of the cerebrum and outside the spinal cord. White matter is on inside of the cerebrum and outside the spinal cord. Which one is correct?
In cerebrum, we have white in gray out. So it should
Uh,
be A.
A. Okay.
And the opposite is there in the spinal cord.
Okay.
That is
Yes.
gray in white out.
Yes. Any other answers? Yeah, I think Sajiji has also joined. Yeah. Hello, Sajiji. How are you? Okay. Yeah. Any other answers? Let's move forward. So it is A, and they are opposite in cerebrum and the spinal cord. In cerebrum, as Parito said, in cerebrum, the gray matter is on outside and white matter is inside. Whereas in case of spinal cord, this arrangement is reverse. Gray is inside and white is outside. Fine. Okay. Which part of the brain is responsible for integrating signals, generating thoughts, and modulating actions? Is it brainstem, cerebellum, basal ganglia, or cerebrum? Anyone? Brainstem. Okay. Anyone else? Yes. Any other answers? Okay. It is the cerebrum. It is responsible for integrating the signals and generating thoughts and modulating actions. Okay. What is
So
the
what is the
function?
function of brain?
Yeah, what you are saying? Can you speak louder?
What is the function? What is the function of brainstem then? It has three different parts, no? Hindbrain,
Yeah,
midbrain,
front
and cell.
and front. Yeah, we will see that.
What? Okay,
Yeah,
okay.
okay. What is the function of basal ganglia? Regulation of no, heart rate, modulation of physical movement, consciousness, or processing sensory inputs. Yes, anyone?
Sir, B, modulation of physical movements.
Okay. Yes. Any other answers? And which part takes care of this consciousness and regulation of heart rate?
It is the thalamus.
Mhm. These two
For
are actually,
consciousness, it's thalamus.
and this is part of brain stem, right?
Okay, yeah, now I recall.
Now, these two are actually taken care by brainstem. Okay, that is why I was not answering because it would have made this question clear. Okay, so it is the modulation of physical movement that happens through basal ganglia. Okay, including the coordination and execution of voluntary motor controls. Voluntary means in which we do things with our own will or we have our own controls, right? Whereas this heart rate, consciousness, these are actually part of the brainstem. These are controlled by the brainstem. Yes, you are saying something.
No, sir.
Okay. So, which part of the nervous system regulates unconscious body functions such as heart rate and digestion? Is it
Now only we
central
discussed ANS.
ANS? Yes, autonomic nervous system. Okay, regulates the unconsciously bodily function such as heart rate and digestion. Right. So now next question is what type of receptors are responsible for detecting change in temperature, pain, and pressure? Is it visible? The question 9.
So it's not visible. Your voice is also cracking in between.
Okay, just yeah. Now it's visible. I hope electricity comes in sometime because at 6:30 it was supposed to come. Okay, so then this problem is not be there. Yeah. So let's answer
Yes,
this.
sir. Now it's
Yeah. What type of receptors are responsible for detecting changes in temperature, pressure, and pain? Is it chemoreceptors, mechanoreceptors, thermoreceptors, or photoreceptors? Yes. Anyone?
for pain and pressure, mechano, but for temperature, thermo.
Okay.
I'll go with mechanoreceptors.
Mechanoreceptors. Okay. They are thermoreceptors. Pain, pressure.
Sir,
Yeah.
even pain and pressure, they can measure.
Yeah. Yeah. They
I
are
mean, detect.
actually. Yeah. Actually, seeing by name, it looks like it will be mechanoreceptors or chemoreceptors, right? But uh, pain and pressure is also measured by the thermoreceptors, including heat and cold.
Okay, sir. Noted.
Okay. So, which part of brain is primarily responsible for processing visual information? I think you have already answered it somewhere. Is it cerebellum, occipital lobe, temporal lobe, or frontal lobe?
Cerebellum.
Cerebellum. So, sorry, cerebral. Yeah. And any other answers? Yes. You remember the picture of brain, right? So, cerebellum is on the
Yes, sir.
top or back,
The biggest part.
the biggest part. Yes. Uh, and occipital lobe.
That I don't remember.
Okay. And temporal and frontal lobes.
No, I'm not sure
Okay.
about lobes where they are located.
Okay. Uh, uh, yeah. Have you ever felt like in general it happens that when you have uh, like when someone hits at the by mistake, if someone hits at the back of your brain, sometimes your visual information is not clear, like
Sir,
you
your
can see.
voice is not clear.
Yeah, hello, am I audible now? Hello.
Sir, your voice is no,
Yeah.
it's cracking in between.
Okay. Okay. Mm, yeah, now.
Yes, sir, much better.
Okay. So uh, what I was saying that if someone by mistake hits at the back of your brain, back of your head, do you feel something like blurring your vision and all sometimes? Have you
No,
experienced this? Uh, like
while hitting
that,
the back of her head.
yeah, if someone hits by mistake or if you fall at by like if you get hit in the back of your brain, have you ever uh, heard this or seen that for some time there will be no visual information, everything will be dark or something like that?
Yeah, yeah, yeah. You mean blacking out, no?
Blacking out, yes, because that information, the visual information that the eye will take the information, but the processing actually happens in the occipital lobe that is situated at the back of our brain. Okay,
Sir, your
located.
voice is not clear.
Yeah. Okay. Yeah. Now, is it clear? So,
Yes, sir.
it is the occipital lobe that is located at the back of the brain that contains the visual cortex. Visual cortex is the part inside the occipital lobe which will process the visual information received from your eyes. Okay, so that's why when you get hit in that part of the brain, you feel blacking out. Okay.
Okay. Yeah. Thank you.
Okay. Which part of the nervous system primarily contains nerve cell bodies and dendrites? Is it
Sir,
gray
the
matter?
screen is not visible.
Yeah, it will come now. Yeah. Is it the gray matter,
Yeah, yeah.
white matter, brainstem, or spinal cord?
Nerve cell, gray matter.
Gray matter. Okay. Yes. Any other answers to this? So, the gray matter contains nerve cell bodies, dendrites, synapses, and is involved in processing and integrating sensory and motor information. So that is the part which contains the nerve cell body and dendrites. Axons are not there. Okay. Now, what is the function of gyri and Scholke in the brain's surface? Is it to increase blood flow to the brain, to reduce the brain's overall size, to facilitate effective packaging of neural tissue, or enhance the brain's ability to transmit electrical signal?
To facilitate efficient packing of neural tissue.
Okay. Yes. Any other answers to this? They uh, are Gyri and Schulke help compact neural tissues, although the precise reason for their presence is not fully understood. Okay, so they facilitate the effective packing of neural tissues. Okay, what is the relationship between gyri and Schulke in the brain? Gyri are deeper than Schulke, or they are unrelated structure. Gyri are folds of brain tissue, while Schulke are spaces between these folds. Gyri and Schulke are terms for the same brain structure. What is it?
C.
See, they are folds of the brain tissue, while sulci are spaces between these folds. Okay. So next is, which imaging technique provides a more accurate structural view of the brain? We are talking about the structural view, how it looks like. Okay. Is it
fMRI.
fMRI? It provides accurate structural imaging compared to CT scans, allowing for better localization of brain functions. Fine. In terms of handedness and speech localization, most people exhibit left-handedness with left-sided speech, right-handedness with right-sided speech, or left-handedness with right-sided speech, and right-handedness with left-sided speech.
D.
D. Right-handedness with left-sided speech. Okay, because local language area are generally localized in the left hemisphere of the brain, which correlates with the handedness in most individuals. Okay. Okay. Damage to which brain region is commonly associated with loss of consciousness? Is it thalamus, brainstem, cerebellum, or frontal lobes?
Thalamus.
Thalamus. Any other answers? It is the brainstem. Remember, some questions back we were talking about this, that brainstem is the part that uh, that regulates this consciousness.
So
Uh,
I agree. We discussed this thing back in some
yeah.
couple of questions back, but
Uh,
in the lecture itself, sir has mentioned about thalamus. Like there are
uh,
various things which depend, which contribute to the consciousness,
uh,
and thalamus is the major contributor.
uh.
So I think it should be the answer.
But where is this thalamus located?
Probably in brainstem, but We have separately that option is given, no? So
Yeah,
it is confusing. I mean, we have
yeah,
both the options, thalamus and brainstem.
yeah. You can say the thalamus also is responsible. Okay, actually, thalamus is something that relays the information, or you can say information station. Like it connects like it relays the information. All the body senses, okay, uh, they are sent to the brain cortex through thalamus, right? Speed, like sleeping, being awake, and then conscious, learning, memory, all these are in the thalamus. Like these are controlled by thalamus. And this thalamus itself is located inside the brainstem. So we can say both of these are somewhat correct, right?
Yes, sir.
Yeah. Which relationship, which best describes the relationship between memory and brain structure? Memory is exclusively localized to specific brain regions, or memory processing involves a network of brain regions. From here, like this is something which from which this artificial neural networks is to inspired, right? So memory loss is always associated with structural brain damage, and or memory functions independently of the brain structure. Which one is correct?
B.
B. That is, the memory processing involves a network of brain regions. Any other answers?
A is also right only, but you have to choose best out of them, right?
Local, it is saying that in only some specific regions of the brain, this uh, memory is there.
It
And
simply
the
means
second,
that every part of the brain has its own function, right?
no, it is saying that it is exclusively localized. Like there is one single area of the brain that contains your memory.
No, no,
And
no.
the
Then it's
second one is that there is involves a network of brain regions. So these two are opposite and they both cannot be true at the same time for sure.
okay. I got
Yeah.
your point, sir. Yes. So
Okay.
B.
B. Okay. Any other answers? It is B because it involves a network of brain regions rather than being localized in specific regions. Okay. Which part of the nervous system is responsible for transmitting sensory and motor signals between brain and body? It is sulcus, gyrus, spinal cord, or white matter. It is sensory as well as motor signals between body and brain. Yes, any answers?
Spinal cord only gives the sensory information.
Mhm.
Spinal cord, probably.
Okay. Yes. Any other answers? Yeah, Sajiji, are you there?
Yes, sir. Spinal cord
Yeah,
has
yeah,
sensory and motor signals.
yeah.
Actually, I have no contradiction. That's why I didn't involve in your. Son.
Not any. Yeah. So it is the spinal cord that serves as the pathway for sensory information from the body to brain and motor commands from the brain to body. And sometimes when we say that there is some reflex action and all these things, so in such cases where like fast action is needed, sometimes the spinal cord itself gives the commands also. It it does not take it till the brain. There only it gives the command, reflex commands and all, and uh, generally it will go till the brain, and the spinal cord is the one that connects it. What is the function of gyri and Schulke in the cerebral context? I think somewhat we have already answered this. They
Yeah,
regulate
they increase the surface.
the surface area of the brain, right? They are raised folds and uh, grooves in the cerebral context. They increase the surface area of the brain, which in a sense actually allows for more neural connection and higher cognitive function. Okay, more this gyri and Sulke, there will be more neural connections and higher cognitive functions. Okay, what is the primary purpose of clinical evaluation in neuroscience? In a sense, why someone actually does this neuroscience evaluation and this thing? Is it to
See,
conduct? Yeah, okay, to diagnose and treat neurological disorders in humans, right? Or it is just to study the anatomy of nervous system. Yes, are we not doing this? Studying the anatomy of nervous system.
that is not the primary purpose, I guess. Diagnosing and then treating.
Yeah, because we are concerned about uh, our well-being and we want to know how to diagnose and treat in case some neurological disorders happen. Okay? Which part of the nervous system contains the largest concentration of myelinated axons? Remember this term, myelinated. We had already discussed it in the previous week. What is this myelinated
Fat.
axons? Fat. And
Fat.
what role does this fat play? Something like this, right?
uh yeah, there'll be like
Yeah,
wires surrounded by the covering of wire basically.
covering of wire. Okay. Yes. Any other explanation? I think Sajiji you might remember.
It is a insulator. So I think it is white matter. It is white in color.
Yeah, that is fine. Like it is white matter, but what is the role of this myelinated myelination in
Myelination
X?
is speed, fast
Yeah, it
movement of this
increases the
action
movement of
potential.
action potential. Yes.
Yeah, action potential is faster, so
It
that
can jump.
you can. Yeah, it will jump like this. Like here locally, it will be there, and then it will jump. Right?
Yes, sir. Fastening of action
Yeah.
potential movement.
Mm, I think still internet is not there. Oh, yeah. Hello. Am I audible?
Yes.
Yes, sir. Yes.
Yeah. So now, now we remember the myelinated axons. Next is which part of the nervous system contains the largest concentration of the myelinated axons. So Sajiji have said white matter. Any other answers to this? Paritosh, do you agree with this?
I don't remember this, so I'll go with
Okay,
whatever Sajid sir is saying.
okay. So it is the white matter, and as a very good logical explanation was that it is since it is fat, it must be in the white matter, right? Since it is fat, it appears white due to lipid-rich this myelin sheath around these axons. Okay, and it looks white in color, so white matter. Okay, which part of the nervous system is responsible for relaying sensory and motor information between the brain and the rest of the body? Is it gray matter, brainstem, spinal cord, or sulcus?
Spinal cord.
Spinal cord. This is the same question with some different options. Right? Serves as the spinal cord serves as the conduit for the sensory information from brain to the body, carrying the sensory and the motor commands between them. Okay, so motor commands will be from body to brain or brain to body. This will be motor commands, right?
But
From body to
body.
brain, will it be motor commands?
No, no, no. It'll be sensory, no?
It will be sensory, uh, and brain to body will be motor, right?
Motor.
So this uh, connect will be done through spinal cord. Fine. So moving to the next question. What type of synaptic potential makes the postsynaptic neuron more likely to fire an action potential? Is it inhibitory synaptic potential, excitatory synaptic potential, or is it related to density of the receptors or the channel density?
Excitatory.
Excitatory. Okay. Okay. Not
I
inhibitory.
have another density of receptors, maybe post synaptic thing,
Yeah.
maybe receptor density is a major role.
Uh, it is actually excitatory. Remember that in the previous one we said that due to this excitatory synaptic potential, the potential itself will become a bit high, and so small stimulus will also be able to raise this to the action potential. It will not be this big. Yeah, even though it was not, it might not have resulted into action. So it is increasing the probability, more likely. That means more probable.
So, sir, the word over here, post-synaptic, was just to confuse us, right?
Yes. Postsynaptic neuron means where the information has been like
Transferred.
transferred. Yeah, after the information or the response has been transferred.
Hmm.
Okay. So as we this is something we have seen earlier also, that excitatory synaptic potential depolarize the postsynaptic membrane, making it more likely for neuron to reach its threshold and fire an action potential. Okay. Next is, what is the primary function of inhibitory synaptic potential in neural processing? Is it to amplify the magnitude of action potential, to decrease the likelihood of firing an action potential, to increase density of receptors in postsynaptic membrane, or to facilitate neurotransmitter release?
B.
B. Okay. Any other answers? Here, see, in both the cases, we are not saying that they will do it certainly. Like in the previous question also, it is more likely, right? That there is a probability. It will increase the probability of action potential. In this case also, it is saying that decrease the likelihood of firing. That means it will decrease the probability of action potential. It will not stop all the action potentials. And in this case, it hyperpolarizes the postsynaptic membrane, making it less likely for neuron to reach its threshold and fire an action potential. Right? Which factors determines the strength of synaptic transmission at a chemical synapse? It is the density of receptors, channel density, concentration gradient, or excitatory potential. Yes, anyone?
Density of receptors.
Density of receptors. Yes, any other answers? Yes, any other answers? Yes, anyone?
So the screen is not visible.
Yeah, just a minute. I am changing the connection now. Actually.
Okay, sir.
Yeah, now it's visible.
Yes, sir.
Yeah. So, what factors determine the strength of synaptic transmission at a chemical synapse? Is it the density of receptors, channel density, concentration gradient, or excitatory potential?
And three.
Three. Okay. Any other answers? Is it? It is the concentration gradient you are saying, right?
Sir, density of receptors. A.
Then okay. Density of receptors. A. Yes. Any other answers? Let's see. It is density of receptors. And why is it so?
I just thought that if the density will be more in the receptor side, so more transmission is going to take place, and hence the strength will be higher.
Yeah. Not more transmission. Yeah. And they will sum up, you can say. Integration or summation of the all of this will determine the strength. Like in the previous class, we were talking something about spatial and temporal things, right? So it will be
Yes.
spatial. Okay. What does the term channel density refer to in the context of neural processing? We are coming up with this term channel density, right? Here also I had put, I think before this also somewhere I put, yeah, channel density. Okay. So what is this term? Yes, anyone? Is it the number of neurotransmitter release sites in the presynaptic neuron? The concentration gradient of ions across neuronal membrane, number of ion channels, per unit area of neural membranes, or the speed of neurotransmitter diffusion in the synaptic cleft. What is this term? Channel density.
Sir, A.
A. Okay. Yes. Any other answers?
Maybe the concentration of gradient of ions across the neural membrane.
Okay. Yes. It is the ion channels per unit area of neural membrane. So it is saying about channel density. So if we just see the term itself, number of channels present like per unit area. And what channels we have? We have the ion channels. Okay. We have potassium channel, sodium channel, chlor chlorine channels, right? So how many, what is the concentration or what is the density of this channels per unit area of a neural membrane? That is called as the channel density. It influences the permeability of the permeability means the excess of like the allowing the movement of ion from one side to another to specific ions, okay, affecting the membrane potential as well as the neural excitability. Fine.
Yes, sir.
Okay. What role does so this was fine. Now here we talked about something as concentration gradient of ions across neural and membrane. In from the first week itself, I was talking about something about gradient. Gradient or potential, we can say, is the difference of like difference of ions or difference of charge. Okay, some at one place there is a different value of charge, other place there is a different value of charge, and that is the potential. Like we were talking about minus 70 millivolt, that is the resting potential, right? Resting potential. It is between the inside and outside of the membrane, right? So here we are talking about concentration gradient of ion across the neural membrane. Okay. Now is what is the role of this concentration gradient in neurotransmitter? In neurotransmitter release and synaptic transmission. It determines the frequency of action potential in presynaptic neutron. It influences the rate of neurotransmitter synthesis in presynaptic neuron. It drives the movement of ions and neurotransmitter across the synaptic cleft, or it regulates the density of receptors in postsynaptic membrane. Yes.
C.
Which one?
C. C.
C. It drives the movement of ions and neurotransmitter. Why? Because it is the gradient. Whenever we are talking about gradient or potential, okay, just try to relate it with electricity, because since I know better about electricity and these things. So whenever there is a gradient or potential, then only there will be flow of charge, electrons, or flow of water, whatever you say, will happen only when there is a gradient, there is a difference. Okay, so this concentration gradient actually plays the role of facilitating the diffusion of neurotransmitter. Even though I can give you an example, let's say that this is a channel, okay, and this is sodium channel, okay. All these three channels are open, but inside and outside we have the same potential. Say here also it is minus 70 millivolt, and here also it is minus 70 millivolt. Will there be any flow of charge between this inside and outside? Yes.
Sir.
Yeah. What you are saying? Hello.
So there is no gradient, like potential is same, so nothing will flow.
Yes. Or we can say on both the sides there are almost the same concentration of sodium ions, maybe, or the net is same in both the sides. Even if there is flow, the if some flow is inward, that same flow will be backward also. Okay, so there cannot, or you can say that they are already in equilibrium. Okay, so there will be no further flow. Okay, so this gradient or this difference of the concentration is the thing that drives the movement of ions as well as neurotransmitters across the synaptic cleft. If there is no gradient, there will be no flow. Okay. What factor directly influences the magnitude of EPSPs? It is the density of inhibitor receptors, channel density. We already know what is channel density, right? Concentration gradient of neurotransmitter, frequency of action potential in presynaptic neuron. Yes. What will be the right answer for this?
Concentration gradient of neurotransmitters.
Yes.
Uh,
Postsynaptic, no? Postsynaptic may not be neurotransmitters.
Mhm.
Postsynaptic must be channel
Channel density, no?
density.
Channel density.
Yeah,
It is talking about the magnitude of the EPSP. Like if something magnitude means this, like this we are taking as resting potential, right? You would. So this amplitude or the magnitude of this EPSP. So which factor will directly influence that? If it changes, this will also change.
channel.
Channel density. Okay. So one answer was this. Second, yeah. Okay. It is none of the both. It is the frequency of the action potential in the presynaptic neuron. Okay. That determines the magnitude of the EPSPs, because
So,
that will, yeah, what you are saying, Paritos.
so why is this like EPSPs and IPSPs? Both of them are somewhat related to the concentration gradient of which is
Neurotransmitter.
going to like the current generation.
Hmm.
Action potential is not at all related to that. I mean, EPSPs will further lead to the generation of action potential.
No, EPSP helps, like if there is an EPSP, uh, remember that if this is axon, right? This is visible, right? So suppose that here EPSP occurred, okay? And this whole, like I'm not drawing the whole neuron. So inside the neuron cell body, there is flow of some ions, okay? So down this, it will actually carry on this gradient. EPSP rate actually increase the potential here, okay? And then moved here. Now, suppose that here a stimulus comes, okay? And due to that stimulus, this this was actually not going to lead to any action potential, but due to this already raised potential here, this led to an action potential. That can happen, okay? But this question is, how will this magnitude, like if it is minus going till minus 20, not minus, it will be less than minus 55, right? So say it is minus minus 60 millivolt, or it is just minus 65 millivolt, that level. How this level will be determined? This this level actually is determined by the frequency of the action potential. How? In the presynaptic neuron, because that will lead to neurotransmitter release. More the neurotransmitters, more EPSPs, and higher the magnitude of the EPSP. Less the frequency of action potential, less neurotransmitter release. Actually, this EPSP is due to this chlorine channel, right? Opening and closing of the chlorine channel. Am I right? It was chlorine channel or sodium channel?
I have to watch the lecture now.
Okay. So it is, what I remember was it was chlorine channel, right? So more the neurotransmitters, more EPSPs will happen, and EPSPs, like you can say, if there are three at thrice this EPSP has happened, so three times this amplitude has the magnitude has changed, or the magnitude has changed for a longer time. Longer time means the magnitude level from minus 70 millivolt, say one EPSP made it minus 67 millivolt, another EPSP for some duration made it 63 millivolt minus, then 62 millivolt, like that. And if there is like here we are talking about 1, 2, 3 EPSP, and if there is only one EPSP, then it would just remain at minus 67 millivolt. So it is how many times these EPSPs are happening, for how much duration, as well as how many times. And this is determined by the neurotransmitters that are released from the presynaptic neurons. Okay. And finally, like they will sum up and make the magnitude of the EPSP, because all the magnitudes will get, you can say, they will get added up to form the when this action potential stimulus happens, they will be the sum total of all the EPSPs down the line. That is, you can say, uh, that was spatial. One was spatial summation, other was what kind of summation?
Temporal.
Temporal. So here the EPSP will be the temporal summation of all the EPSPs that has happened between one action potential to another action potential. Fine.
Yes, sir.
In neural processing, what does effect does an increase in channel density have on the postsynaptic neuron? Here we are talking about channel density. And what is channel density? Yes, anyone?
The number of uh, channels per unit area.
Number of channels per unit area. Okay. So, what effect does an increase in channel density have on the postsynaptic neuron? Yes, it increases neural excitability. It increases speed of action potential propagation. It increases likelihood of firing of an action potential, or it decreases the concentration gradient of neurotransmitter.
Is it C?
C. Okay, it is increased. Okay, right. So an increase in channel density will allow for more ion channels to open in response to any neurotransmitter binding, okay, leading to increase in depolarization, like there will be fast depolarization as well as more depolarization, and that is why there will be higher likelihood of firing of an action potential, okay. So large number of channels will open at the same time, and so this action potential is more likely to happen in case the channel density is more, it increases, okay. What is the consequence or effect of a decrease in density of inhibitory receptors? Inhibitory receptors in the postsynaptic membrane. This is not IPSP, it is talking about receptors, okay. It amplifies the magnitude of inhibitory postsynaptic potential. So it is saying that the magnitude of IPSP will increase. It will reduce the threshold for firing an action potential. It increases the likelihood of synaptic fatigue. It decreases the effectiveness of inhibitory synaptic transmission. Yes. Anyone? Yes. What might be the right answer?
A maybe it amplifies the magnitude of inhibitor.
Yes. Okay. It is saying a decrease in density.
It reduces threshold for firing.
Threshold is fixed, like with that, no, minus
Mm,
55. Threshold cannot change.
change.
So D.
B or
D may
D.
be the
So let's first decide which one, A, D, or A or D, like YA or YD. Uh, Parito said D, right? Yeah. So YD.
I mean, the inhibitory receptors will be less, so the I believe the magnitude or the de-amplification should take place instead of the amplification of IPSPs,
Hmm.
because something which is reducing uh, the action potential, it can't just increase the magnitude. I mean, I'm just guessing it.
Okay. Uh, yeah, and Sajiji, your was A, right?
actually totally confused, sir.
Okay, A and D. Okay. So it is D, certainly, because I think if it was increase, then we can say that it would have been A, and that might be the reason that you also got confused at beginning. So if there is a decrease in density of this inhibitory receptors, so it decreases the responsiveness of postsynaptic neurons to inhibitory neurotransmitter. So if there are less receptors, so it will not act very easily to inhibitory neurotransmitter. So there will be less number of hyperpolarization, so leading to, we can say, decreasing the inhibitory this IPSP. The magnitude of IPSP will decrease in this case, and that means uh, it decreases the effectiveness of IPSP or inhibitory synaptic transmission. Okay, so we can say that it will support more if we have less number of inhibitory receptors. Uh, there will be less amplitude of IPSP, less magnitude of IPSP. Fine. So, any questions till here?
So,
Okay. So that's all for today. I'll be posting all this in the like in the sheet. And
sure, sir.
okay.
Thank you.
Thank you, sir.